also starting a new thing. It's solving equations. I think we did this already.
Okay.
With variables on both sides.
Okay.
And also now she has problems with no solution.
Okay, cool. Like this.
Well, not exactly. We're not having multiple variable problems.
Okay. This, you'll notice, has no solution. There's no way x plus y could be equal to 2 and also be equal to 3 at the same time. So there's an example of something that would have no solution.
Yeah, we actually went through the first problem.
Okay.
And it had no solution. It was 2 minus 6b equals 1 minus 6b.
Yeah, notice that if I add 6b to both sides, I get 2 equals 1. Whenever you end up with that, that means no solution.
Mm-hmm.
Or a number equal to 0 or anything like that. Okay, you want to go through some problems?
Yeah.
Go ahead and read them.
So the second one is negative 6 minus 5 equals negative 6x.
Like that?
Yeah.
Okay.
Equals negative 2x minus 13.
Okay.
So, first things first, you would add negative,
Let me make a suggestion. We can certainly do this the normal way, and I know you know how to do it the normal way. We'll do it the normal way, but notice that every single term has a negative sign in front of it.
no.
Couldn't we divide everything by not minus 1, get rid of all 4 negative signs, and the problem will be a lot easier?
Oh, yeah.
Now solve it.
One moment. Gonna just write that down. And so now we can subtract 2x from both sides and get 4x plus 5 equals 13. And then of course you subtract 5 and get 4x equals 18.
8 is 13 minus 5.
Oh, whoops, I accidentally did plus. Okay, my bad.
One of the reasons I did this first step was to make sure I didn't make mistakes mathematically. Because it's a lot easier to make mistakes if you're working with negative numbers than it is when you're working with positive numbers.
Yeah.
Okay, so we solved this pretty easily doing it. Now let's go back and just make sure that it solves the same way without that first step. Well, you'll notice how much harder it's going to be.
Yeah.
Well, not so much. Not if I move my 6x to the other side and my minus 13 to the left side.
Yeah, and then you get positives anyway.
Yeah, then you get 8 equals 4x, and we're done also. So I didn't really need to take that first step. But it's useful to know that you could if you wanted to. In other words, if you have an equation that negatives are in front of everything, you can just change them all to positives.
Yeah.
Okay, what's the next one you got?
So the next one is... One moment. Okay. 8x plus 3 equals 3 plus 7 x minus 7.
Like that?
No, 3 plus 7x, and then minus 7.
Okay. Okay.
And so the first thing you have to do is combine like terms. And so the way I usually do it is that if I see the same number on both sides of the equation, I just cancel them out.
Beautiful.
So
that's exactly what you're supposed to do. That's much better than having 3 minus 7 and then have to deal with that. In other words, that's a valid shortcut.
Yeah, and so then you get 8x equals 7x minus 7, and then you subtract 7 on both sides, and you get equals negative 7.
Okay, good. I got a feeling you know how to do all of these.
Yeah, except the thing is, I've been looking back at my homework, and I've been making a lot of, like, just simple mistakes. Well, not a lot, but some simple mistakes, and I want to be able to fix that.
Okay. The way to avoid simple mistakes, everybody makes them. It's just a question of how much. Do you make it 1 out of 100 calculations, or do you make it 10 out of 100 calculations? It's a big difference. You can get away with 1 out of 100 mistakes, but you can't get away with 10 out of 100. So the solution is to pay extra attention to detail. Know that when you're solving math problems, you cannot make one mistake. If there are 9 steps to a problem and you make one error, you're getting the answer wrong.
Yeah.
Okay, math does not allow for imprecision. And there are calculus problems where there are like 12 steps to solve it. So you can have no error, no room for error. So go ahead, let's go through whatever you want to go through, and we'll have you come up with it, and I'll see if I can figure out why you maybe make a mistake when you do. So let's read me the problem and then read the next line.
So the next one is, so the next one is 6v plus 7v equals 16 plus 3v minus 1 minus 5.
Is this a z of v?
Yeah.
Okay. Next line. I might add that there is a, yeah, go ahead. Give me the next line. What would be your next step?
So the first thing I would do is combine like terms on the separate side of the equation.
Okay.
So I would go, like, I would add 60 and 70, not 3v to all that.
Okay.
And stuff.
What happens when you combine all the like terms on the right side of the equation?
You get 10 plus 3v.
Okay. Now what? What's the next line?
Then you subtract 3v and get 10v equals 10. And then you divide by 10 and get v equals 1.
Okay. You're going to have to do a lot harder than this to challenge yourself.
Yeah.
Can we start from the most difficult ones and go up?
Yeah.
Let's try that. I mean, I'm not sure where the difficult ones are. Usually they're the ones at the end of the page.
Well, the really difficult ones are up in just a second. So.
Okay, whatever. We can just go through them all. That's fine. It'll be good practice for you, working on your detail and getting your numbers perfect.
Yeah. And so the first one is 14 plus 2x plus 7 minus 4 equals x minus 5.
Okay.
And so the first thing is to combine like terms.
Okay.
And you get negative 11 plus 2x plus x minus.
How'd you get negative 11? Where'd you get negative 11?
It's a negative 14.
Ah. Okay. So it's minus 11 plus 2x equals x minus 5. Now what?
Then I would add 5 to both sides.
Okay. Next line.
Next line is negative 6 plus 2x equals x. Then you subtract 2x from both sides and get negative 6 equals negative x. And then pretty much you just divide by negative 1 and get 6 equals x.
Okay. So let's talk about one thing here. Is there a way we could have done this to minimize the chance of making a mistake?
What was that?
Huh?
What was that? You came through kind of bad.
Yeah, our audio is a little choppy here. It's making it difficult to understand everything you're saying. Can you hear me okay now?
Yeah.
All right. Notice that when you did this problem, you ended up with a negative in front of the x at this step right here.
Yeah.
Usually, I'm a lot more comfortable solving equations when I try to leave stuff positive if I can. Okay? So, if I go up to the second, when I look at this equation, I know that I got to gather my x's on one side and all my numbers on the other. That's all there is to it. I can look at it as, okay, let's gather like terms on each side of the equation, but it's not really necessary. In other words, I know that I got to get x's on one side and all numbers on the other. Which side do I want to get the x's on, the right or the left? Notice that if I move the 2x over to here, I'm going to end up with minus x. But if I move this x to this side, I'm going to end up with positive x on the left side of the equation.
Oh.
So I would choose to do that immediately. In other words, I know that I've gathered all my x's, I'm putting them on one side of the equation, and I want it to be a positive x, so I'm going to put it on the left. Now, I just have to move everything else to the right. Well, what's everything else? If I move that over there, I put it over there, change its sign. If I move that over there, I put it over there, change its sign. Same thing here. I still have a minus 5. Now, if I work through all those numbers, I get 6.
Okay.
So I don't have to deal with the problem of having minus x equal to something. Now, it doesn't matter whether x is equal to 6 or 6 is equal to x. So the way you solved it was completely legitimate, perfect. Your teacher wouldn't have even said anything about it. She would not have made the comment that I made. The only reason I made that comment is because sometimes there's little tricks you can use to minimize the chance of a mistake. And that's one of them as far as I'm concerned, is working with positive numbers when you can and not negative numbers.
Yeah.
In other words, if I had something like this, let me rewrite this. I'm never going to move my 2x to that side and my 2 over there. That's going to give me minus x equals minus 9. unnecessarily too many negative signs. So
Yeah.
the moment I look at this problem, I can see that I want to move this x to the left. So I'm going to end up with x. I'm going to move the 7 to the right, all positive numbers. Just a tip to use when you're solving some of these. Okay, well, yeah, what else you got?
So, problem after that is up here. The next problem is negative, wait. Okay, 1 minus 6n equals negative 15 minus 2n minus 2n.
Minus 2.
N.
Minus another 2n, like that?
Yeah.
Okay.
So, first, you combine like terms, so that 1 minus 6n equals negative 15 minus 4n. So then you would add 6n to both sides.
Good. Whenever I'm doing this, I don't need to do that in 2 steps. I can do that in 1 step. In other words, whenever I'm moving all the rest of the variables to another side and the rest of the numbers to the other side,
Okay.
I feel like it's kind of a waste of time to take 2 steps and write it twice. You see what I'm saying?
Yeah.
Okay, do you agree?
Yeah.
You want to try it like that? It's also, there's a danger in that it's easier to make mistakes. So it actually introduces an opportunity for a mistake just because I'm doing 2 steps in one in my head. But nonetheless, you might still like it. I bet you would. Let's have you do it that way, and I'll see how many mistakes you make doing it.
Okay. So the next one is 5 plus 8n equals 5n plus 2.
Like that?
Yep.
Okay.
So
What's the next line if you do both steps at once?
first you subtract 5 from both sides and subtract 5n from both sides.
Okay.
Then you get 3n equals negative 3.
Good.
And so then you get n equals negative 1.
Okay. Worked well enough there. Okay.
So next one after that is 8, negative 8, and then in parentheses, x plus 1 equals negative 6x minus 20.
Like that?
Yep.
Okay. What's first step?
Distribute, so you get negative 8x plus negative 8.
Let's just do
Equals.
that. Okay. In other words, we don't need to write both the plus and the minus there.
Okay.
Okay.
And so equals negative 6x minus 20.
Okay.
Then you would add 8x to both sides
Good.
and add 20 to both sides.
Okay. So what's that?
And that would be, let me think for a moment here.
It's okay. And you can do it in 2 steps if you want. I'm not trying to force you to make that shortcut.
So you get 12 equals 2x, and then you divide by 2 on each side, and get 6 equals x.
Okay, good. So far you haven't made a mistake doing any of that. Okay, what's next?
Then 8a plus 9 equals negative 5, and in parentheses 3 minus 2a, then the parentheses stop, plus 8.
Okay.
And then first you distribute to get 8a plus 9 equals negative 15 plus 10 plus 8.
Plus 10a.
Oh, 10. Right. I forgot to write that down, actually.
Okay.
And then you would combine all like terms. You get 8a plus 9 equals 10a minus 7.
Okay. Now what?
Then, if I did it the way you would do it, you would subtract 8a
Good.
and add 7.
Okay, so what's the last line, or the next line?
So the next line is 16 equals 2a. And then you divide both sides by 2 and you get 8 equals a.
Okay. Do you agree that it makes more sense to move the 8a to the right than the 10a to the left?
It's way easier than...
Always try to think kind of in advance as to what's going to produce a negative number, and let's avoid that.
Yeah,
In other words,
it's way easier. It's way easier to doing something like negative 7 plus 20. It's way easier to do 20 minus 7.
I agree. Okay, what else we got?
And then after the next two, we get to the really hard ones.
Okay.
9 plus k equals negative 8, and in parentheses 7 plus 8k.
Okay, distribute the right side.
So you get 9 plus k equals negative 56 plus negative 64.
Okay. The moment you said plus, I thought you had made a mistake.
Oh.
In other words, it's not typical that you're going to do it. You're not going to write it like that.
Okay.
I'm never going to write it like that. In other words, I immediately, when I distribute that to that, it turns into a minus.
Okay.
Okay? It just is going to confuse the issue if you put a plus in front of it. Okay, so I got 9 plus k equals that. Now what?
And so then you have to add 56 to both sides. And then...
Is that what you want to do?
Um...
Look at the variable first. Which side are we going to end up on the variable? We going to end up with the variable on the left side or the right side?
You want it to be on the left side.
Because that'll give it a positive coefficient.
Yeah.
So I don't want to move that term. I'm going to leave it over there.
So you want to add 64k.
So what's the next line?
And you also want a minus 9. Okay, so you get 65k equals then 56 plus 9.
Sometimes you can't avoid the negative.
Yeah, and then negative 65.
Okay.
And then you get k equals 1.
Nope.
Really? Oh, negative 1.
Okay. Why did you make that mistake, do you think?
Because I forgot about the negative.
Did you? Okay. You just overlooked it? Okay. Those are the kind of errors you want to try to avoid.
Yeah.
And those are very typical, simple arithmetic errors. Okay, what else?
5x equals 2, and in parentheses, x minus 6.
Okay.
And so then you distribute, and you get 2x minus 12.
Okay.
Then you subtract 2x from both sides. You get 3x equals negative 12. Divide by 3. X equals negative 4.
Okay. All right. Give me these hard ones.
So, problem number 15. 7.886 in parentheses 0.7 minus 5.8n, then the parentheses stop.
5.8 what?
5.8n, and then plus 6.1n equals negative 129.25172.
Okay. This is not any harder than the others. The only thing is you got to use a calculator.
Wow.
I mean, you don't have to use a calculator, but in other words, the only thing that makes this problem different than the others is we're not using integers. We're using decimals. That doesn't make it harder. It just makes it more effort. Let's not have you multiply these out by hand just because of the time issue. It'll take too long. So use a calculator. Let's distribute this.
Okay. So let me pull out my calculator from my phone really quick.
Okay.
Here it is. Okay. So first you distribute and get 7.886 times 0.7.
You don't type that into your calculator, do you? The 0?
No.
You just type 0.7?
Yeah, it automatically puts it at 0.
Is there a reason everybody reads it? I always read it as 0.7. I never read it as 0.7.
Yeah, that's just, usually I just read what I see,
Uh-huh.
and it has 0.7 on there.
Oh, no, I understand. Does the teacher like you to use the 0 when you're verbalizing it? Or if you give an answer, would she count this wrong?
No, she doesn't really mind.
Okay.
Anyway.
All right. To me, I've always thought of it as a bit of a waste of time and writing. In other words, that leading 0 never has any meaning. It's like writing 0.70. I would never write it like that, or adding 47 zeros following it. It's just a waste of time to do it. It doesn't change the number. So to me, I tend not to write that. There's no necessity for it. I don't put it in. You do it however you like. And however, oops, I might have lost you. Still there, David?
Yeah.
Oh, okay. I heard a tone. Usually that means I've lost the audio, but not there. Okay, so what'd you get when you multiplied that by that?
So the first one was 5.5202, and then you got to do the next one, 7.
What's the sign going to be on it?
It's going to be negative.
Okay.
5.8. And so I got negative 45.
45?
Yeah, negative 45. So negative 45.7388. And then you do plus 61n.
Hold on. There's something else that goes after this number. Remember, we're multiplying this by negative 5.8n.
N. You put an N after it.
Okay. And then that plus
6.1n.
1n
Negative
equals that number there.
29.
Okay. Now, let's combine like terms.
Yeah. So
Since they're complicated decimals, let's just do one thing at a time. This is definitely not where I would try to do it all 2 steps in one, because I can't do it in my head, and I don't want to have to pull out a piece of paper. So what's the net ends that we have on the left side of the equation?
net ends?
In other words, add that to that.
Oh, okay. So first you can, okay, one moment. You get 51.
Hold on. Hold on. You got a negative 45 and a positive 6.
Oh, okay.
That's the way to look at it. Forget these decimals for a moment. Make sure you know what the ballpark figure is going to be. The ballpark figure is not going to be 51. It's going to be 39, around there, right? Negative 39?
So negative 39.6388n.
Okay. I am a huge believer in ballparking because it keeps you from making the mistake you just made. The moment you said negative 51, I knew you'd made a mistake because I knew the ballpark had to be near minus 39. So if you kind of have an idea in your head when you look at it, what range should our answer be in, you would immediately pick up that mistake the moment you did it, or you wouldn't have made it in the first place. Okay, what about the right side of the equation?
And then, so then you have to subtract 5.5202.
Okay, so what's our answer?
Both sides, and I'm just going to do that with my calculator.
Absolutely.
Actually,
I
don't need to.
Make sure you know the ballpark number, so if your calculator gives you a mistake, you'll recognize it instantly.
Yeah.
Approximately, what should we be? We should be approximately 134, right?
Yeah, negative 134.
Negative 134, correct. Okay, so make sure your calculator gives you something very close to that number.
And so...
Because it's easy to make a mistake on a calculator when you're dealing with pluses and minuses. Real easy.
I got negative 134.45372.
Okay. Negative 134 point what?
4, 5.
Okay. Hold on. Let's stop for a moment. I know this cannot be a 4. Why? Because this is 0.5 and this is 0.2, and I'm adding them together. Got to be a 0.7.
Oh, I did not add the 5 in there. I just did 5.202.
Okay.
So let me just redo the decimal plot.
But you can see the value. In other words, I caught your mistake and I don't have a calculator in front of me. I didn't do it on paper. I was just looking at it. So I knew that that 4 couldn't be right. And it's helpful to be able to do that.
So, negative 134.77242.
The third digit is a combination of 0 and 1. Right?
Did I make a... Yep. Okay. So, 1242.
192. In other words, let's look at that. What I'm doing, I'm going to put my 5.5202, lining all the numbers up under properly. And it's a negative, so I know I'm going to add these, right? So that digit's got to be 7. That digit's got to be 7. That digit's 1. That digit is 9. And the last digit is 2 because it's a 0 right there. Okay?
Okay, and then you have to divide both sides by negative 39.6388.
Now this one I got no tricks. Whatever number you give me, I'm going to write down. I know it's got to be positive. I know it's going to be about 3 and change, just from looking at it, because 39 goes into 134 about 3 times. So, 3 point what?
That's what I'm doing right now. I'm going to do it on the calculator. I'm not.
I hope so. I hope so. You do this by hand and we'll be here till 9 o'clock.
Yeah.
But even when you do a problem on a calculator, it's helpful to know what the answer's range should be, what its ballpark should be. Because it's real easy to make mistakes on a calculator when you type in the buttons, especially when you're doing pluses and minuses. It's real easy. Your calculator probably has a subtraction sign, and it probably has another key that's a minus. Do you use the TI-84? What calculator do you use? Just the one in your phone?
Yeah, it's a half touchscreen, half keypad.
Okay. Well,
So
I guess what I'm trying to say is all calculators tend to be different, and unless you're really used to using your calculator, it's easy to get the sign wrong.
Yeah.
So that's why I'm a big believer in the ballpark, even if I'm going to do that using a calculator, which I would. But it'll help prevent mistakes you make when you type into your calculator.
Yeah, I got n equals 3.4.
Exactly?
Yep.
All those decimals, and it came out exact.
Yeah.
3.40000, huh?
Yeah, 134.77192 divided by 39.6388.
Good. And that's the way I would have put it into the calculator. I would have omitted the negative signs.
Yeah.
You didn't put the negative in.
Mm-hmm.
You don't need to, as long as you know your answer is positive.
Yeah.
All right. So these are hard not to set up and do. They're just hard to keep track of all the decimals they give you.
Yeah, and these are the problems where I usually get the most things wrong, so I'd prefer to go over these.
Yeah, let's do another one then.
So, next one.
This time I'm going to start it way on the left because I ran out of room last time.
It's actually way less long.
Oh, good.
Okay. Negative 6.7, and then in parentheses, negative 5.6 minus 6 equals
M.
M. M. Oh, and this time there's only one variable. Okay, that's nice. Equals 246.56.
M? Or just that number?
No.
Just that number? Okay.
And so,
What's the next line?
First you distribute.
Okay.
And should I do that on a calculator again?
Sure.
So, first you distribute.
The stuff I do in my head is usually single-digit stuff. Once I get 2 digits, if you give me this problem, I am not going to do that in my head. I'm going to multiply it. I'm going to either multiply it out longhand or I'm going to use a calculator.
Yeah, the max for me is 12 by 12. Anything under that?
Well, good. Anything less than that, and you should do it in your head. You shouldn't do it on a calculator. It'll make math easier for you if you can do those in your head.
Yeah.
Okay.
So, you get 37.52 plus 40.2 M.
Okay.
Equals 246.56.
Okay. Next line.
So the first thing you do is subtract 37 from both sides.
Okay.
And you get 40.2 M equals, one moment, 209.04.
Okay.
And then I'm just going to divide with my calculator.
Yeah, you don't need to re-enter that number. Just divide your answer by 40.2.
Wait, one sec. That's just one way.
What calculator do you use on tests? Is it your phone calculator?
No. Like, we never get problems as hard as the one we did earlier on tests.
Okay.
And never these either.
But
So,
what calculator do you use?
We don't use calculators on the tests generally.
Okay.
But she would let us use our calculators.
Right. Okay. Okay.
We had a problem
But the one you always use is the one on your phone? You don't have an independent calculator like a TI-84 or anything?
Yeah, I do have a graphing calculator. But it's upstairs in my room.
Okay.
And it's quicker just to do this since I don't need to do anything really fancy.
Okay. The new one they're going to make you get next year? Are you in 7th grade or 8th grade?
7th grade.
Okay. They may or may not make you get it in 8th grade, but by the time you get to 9th grade, they're going to make you get the TI Inspire CX, which is the greatest calculator since sliced bread. I just got one a week. I got one a week ago. This thing will do anything you can have to do mathematically. It'll do. It'll factor. It'll do anything. It's unbelievable. I can't believe they let kids use it on tests, to be honest. So what'd you get for a final answer here when you divided this by 40.2?
M equals 5.2.
Again, they made it come out to be a nice number. Okay.
Yeah, nice features of numbers.
Mm-hmm.
So the next one is fractions. Yay.
Okay.
4 1/3 and then in parentheses, 4 2/3 p minus 1/4 equals 3,289 over 36.
Okay. It's a
And
good way
really
to it's a good way to proceed here. We got a lot of choices as to what to do.
Really quick, I'm going to try and see if that simplifies the last number.
Let's not.
Okay.
Okay, and I'm going to show you why.
It doesn't.
We're going to do this almost manually.
Okay.
Okay. First of all, let's put these into improper fractions. I'll show you why.
So
How many thirds is 4 1/3? When I convert this to an improper fraction, what do I get?
13 then this is 14/3 p minus 1/4 equals 3,289 over 36.
Okay. Now distribute before we do anything else.
So first you distribute.
Now look at that, 13 times 14. That's exactly the one I said I couldn't do in my head, and I can't. What is that number?
Let me pull that up. 13 times 14.
182. I can do it in my head after all.
Yeah. 182. So
Over what?
182 over 9
Okay.
p
Okay.
minus and then minus 13 over 12 equals 3,289 over 36.
Okay. Now I wanted to get to this point because I want to show you a step here. If you can eliminate denominators in one step, do it. It'll get rid of all the fractions for you at once. What can I multiply every term in this equation by to get rid of all three denominators?
3.
No, I won't do it.
Well, you would
Notice that if I multiply this by 3, it doesn't get rid of the denominator. I'm still going to have a denominator of 3.
Oh, get rid of the...
Yeah, I want to multiply every term by one number. Let's call it a common denominator.
Yeah.
And it will eliminate all three of these denominators at once. What is that number?
That's 36, right?
Exactly. So I'm going to multiply that by 36, that by 36, and this by 36. And now notice what I can do. I can simplify the 36 over to 9. That becomes a 4. I can simplify this 36 over 12. That becomes a 3. And this 36 disappears. So now what's 4 times 182?
Setting out my calculator.
728. P
So
minus, what's 13 times 3?
minus 13 times 3 is 39, I want to say. Yeah.
So in one step, I've eliminated all fractions. And now I have a problem that's very easy to solve. So when you see a lot of denominators in an equation, see if you can find one common thing to multiply all of them by to get rid of them all in one step. And at this level of algebra, there's always going to be an easy common denominator, like 36 in this case. In other words, they're not going to make this an 8, which then becomes difficult to find that common denominator. But I like this step. Whenever you have a lot of denominators that you can get rid of with one single multiplication, I like to do it. So what's the next line?
The next line, you have to add 39 to both sides. You get 728. P equals, 1 moment, 9 plus 8, 2, 3,328.
And then what's P equal to?
And then you divide by 728.
I'll bet you it's a whole number, just the way they're doing things.
I will say, I bet it's 4.
Yep, that's what I would have guessed, but it's not, is it?
It isn't?
No. Go ahead and do it in your calculator.
Okay.
It's going to be 4 point something. No, maybe it is 4.
Yeah, I'm thinking it's 4. It's... Oh, whoops.
Let me practice using my new calculator.
4.571. Wait, actually, she taught us a really easy way how to do this. You just pretend it's a fraction. And so you would just simplify
32 sevenths.
Yeah.
Which is 4.57143.
Yeah.
Well, they fooled me. I thought that they were going to give us a nice answer like all the other ones. Okay. I'm a little confused. When you said she taught you an easy way to do this, why would you not always do this on a calculator?
Well, sometimes there's questions kind of like this, but just the answer comes out it's not as complicated.
Okay.
But, she would just have us turn it into 3328 over 728 and turn it into a fraction.
Oh, okay. Well, that's dividing both sides by 728. Okay, so then do what with that? In other words, that's hard to reduce.
Yeah, but
I can divide it in half a few times.
Yeah, it's easier.
I might get it to 32 over 7, but it's not going to be easy. I'm going to have a hard time getting that down to 32 over 7, even though that's what it's equal to. Without a calculator or doing it manually, I don't know how I would do that. But when you see a problem like this is always a calculator problem, no matter what level of math you're at, except maybe if you were at 5th grade math. 5th grade math, they may actually make you do that, but not...
Yeah, I did not like 5th grade math. They did not let us use calculators at all.
Right, right. And so they force you to do stuff like that, yeah. But not after... Okay. All right, how about if we call it, you got any last problems you want to look at?
There is just one more of these factor problems.
Okay, let's do it real quick. 5.
So 81 and 2/5 equals 17 over 5 plus 14 over 3.
You're breaking up. I'm losing your words. 81 and 2/5 equals 17 fifths plus what?
14 over 3. And in parentheses, 3 2/3 x plus 4.
Boy, I couldn't hear anything you said. Is that correct?
Plus 1.
Plus 1? Okay.
Not 4.
Okay.
Yeah.
All right.
So then,
So what are you going to do here?
so we have to turn them all into, well, I would turn them all into improper fractions.
Well, before we do that, we might not have to do that.
Well, don't you have to, in order to multiply, don't you have to make improper fractions?
What if I multiply this by 15? How do I multiply 81 and 2/5 by 15?
Oh.
15 is going to be the number I'm going to multiply everything by, right? That's a common denominator.
Yeah.
Well, I can multiply 15 times 81 and then 15 times 2/5 and then add them together.
Okay.
So what's 15 times 81?
Have you gotten my calculator? $1,215.
What's 15 times 2/5? Do that in your head.
Let me,
Multiply those.
Six.
Okay. So that's the left side, is that number. Now I still got to multiply everything by 15 on the right. So what's 15 times this?
So 15 times 17.
No, don't do it that way. Reduce it first. Cancel this 15 with this 5.
So you get 3 times 17.
Which is 51.
50.
Now multiply 15 times that only. We don't need to worry about what's inside there yet.
And so then you multiply 15 by that and get, yeah, 5
Right.
times 14.
Which is 70. Now I'm going to leave this exactly the same for a moment. So now I've accomplished what I set out to do, which was to multiply every term by 15. And in fact, I treated the 81 separate from the 2/5. I just got to make sure I add that, because this is really 81 plus 2/5. So I can multiply 15 times this. I just have to multiply it by each number and then add them together.
Okay.
Okay. So now we just have to distribute this. So, and add this. So this becomes 1221. I'm speeding up here because I got a 5:30 session I got to go to. And it's 5:32 right now. So let me just explain how I'm going to do this. I'm going to multiply the 70 times the 3. Then I'm going to multiply the 70 times the 2/3. Then I'm going to multiply the 70 times the 1.
Okay.
Okay? Now, I'm basically ready to gather all my like terms and solve it. The right side has 121 in numbers, so when I subtract that, I get 1100 equals 210. Excuse me, there is a plus there. So it's 210 x plus 140 over 3x. In other words, when I multiply the 70 times the 3x, I get this. When I multiply the 70 times the 2/3 x, I get that.
Okay.
So now I have to add 210 plus 140 over 3. So now I have to turn that into a 3 goes into that 46 2/3 times. Move the 70 over to the other side, making it 1030. Add these two together. I got 256 2/3 x. Now I can divide on a calculator 1030 by 256 2/3. That'll give me x. Okay?
Yeah.
All right, David. I will talk to you next Wednesday at 4:30.
Cool.
All right. Good night. Have a good week. Bye-bye.
You too.